a little bit off. But so what happens is you plug in your computer into a wall and some voltage gets sent to your computer, right? Then from there, the computer routes these voltage into circuits, which you can just think of like as wires. And these circuits can be turned on or off, or 1 and 0 respectively, which will make a little bit more sense in a minute. So the computer, what this is doing, your CPU and other components, are collecting a bunch of on and off values in your computer, and from that we can make data. So the way that that works is we have like our 1s and 0s, and that kind of makes sense, okay, on, off. But how do you get into more like complex data? Like imagine you have a 3D matrix of data, right? So we're trying to represent some 3D space. This is where we get to like binary and how computers actually organize data. So you're probably familiar with like, counting on your fingers, the decimal system. The difference with binary is that when you get to 11, you reset your hands, right? So you go to 11, 12, 13, 14. With binary, it's just base 2, so it's 0, 1, 1, 1, or 1, 0, 1, 1. So you're just going over like that. And that's kind of how computers are storing their data. So it's almost like from that, they can create like big numbers, right? You can represent 4, 5, 4 million, different numbers with that. And from that, we kind of get like the whole world of computing kind of opens up for the computer and for us as programmers. So to me, that's like one of the greatest inventions of mankind is we were able to take like raw electricity and turn it into stuff, software and things that we can use. So it can do math, it can store data. And so how we kind of represent it is that binary numbers are stored in data, and we call those bits. And then from those bits, we turn them into things that humans can read. So we get our data types, which will make a little bit more sense in a minute. So I have them like scattered throughout the talk of like fun facts about like how many bits and how many bytes are in these different types. So it's just something to keep in mind. I wouldn't worry about it too much if you're starting out programming, but it's good to know if you like get real into it. So there are 8 bits in 1 byte. So if I say something's 4 bytes, that's 32 bits. Okay, so we got data out of the way. So what is computer programming like at its basic level? All software that you can imagine is always just data and data flow. It's what data are we changing and how are we changing it? And that's kind of where programming languages come in, because it's just different ways that you can organize your data and have it flow through to give you some desired output, from an operating system to a video game. So like the best analogy I could make is that a programming language is like a spell book. You list out your spells, and then all of these different things kind of happen and things start to flow around and work how you want. So the actual like incantations, if you will, is like what we call our syntax. So it varies from language to language. Tonight we're going to be going over some of the basic stuff for C# in specific in Unity. So then whatever you're writing your code out in, eventually it has to get to a compiler, and the compiler compiles it down to an executable. And then from there, your computer can run it. Changes a little bit like on the web and stuff, but pretty much that's how it is. So in programs, this is more like what you kind of need to know, is that in programs we store our data in variables, and then we manipulate that data through functions. So let's go over those. Okay, so this is just a real basic line of C# code. We're declaring a variable, and there are a couple different parts to this. So the first part is the type, which we write out as int, and that variable type in specific is an integer, which is just a whole number, positive or negative. And then we have our name, our identifier. So you can name these whatever you want, but usually it's pretty good to have them be descriptive of what type of data they're representing. And yeah, it's good practice to write them camel case, so like I have written there. And then at the end of every programming statement, you have a semicolon in C#, which indicates the end of a statement to your compiler. So in Python, it's a little bit different because you have like spaces and stuff, but in C#, it's always a semicolon. Okay, so then a fun fact is there are 32 bits or 4 bytes to an integer. So if you were working with constrained memory, you would know, okay, if I want to manipulate this, then I need to know here's how much memory I have, and you can go down into that. But like, if you're pretty familiar with RAM, you would know like we have 8 gigabytes, and that's quite a bit. to play with and different things like that, and CPUs vary and all that. Okay, so this one's a little bit different. It's also a declaration, but if you notice, we're initializing it with a value of 5. So that is called the assignment operator. So the equal sign is an assignment operator. Essentially what we're saying here is that age is value 5. It's a little bit weird because normally it's not usually how we use an equal sign in math and stuff, but essentially what we're doing is assigning the value of 5 to the variable age. And then we end it with a semicolon, just like before. Okay, so in C#, this is a comment, so just backslash twice, and then if you're in Visual Studio, it's all green. And nothing after that is compiled, so you can write whatever you want. If there's other programmers you're working with, it's super helpful for them to look at, what it is. And then next we have float, so it's a little bit different type here. And it's designated by the float variable type, but they also have an F in C#. So floats must have an F on the end, otherwise your compiler will yell at you and say, I don't know what this is. And the best way to describe a floating point number is that it's like a decimal, but it loses precision at really high values, so like 10,000 plus. But what it's good for is like really fast mathematical operations, which is super good in games, right? Like if you're moving at some like speed and you want to do some like complex 3D math, a floating point number is really good. So they're pretty much good for most games, but it's something to be aware of if you're using them at like super high values. Or a perfect example is like if you're in Unity and you are like, you just keep like doing an endless runner and you just keep going and going and going, you're going to run into an issue. Question?
There's also doubles in C#, right?
Yeah. Yeah.
What's the difference between a float and a double?
Yeah, you want to
Can you repeat the question for the stream?
Oh, sorry, for the stream. The question was, what's the difference between a float and a double? A double is more precise, and it is also less fast. So that's the big difference. If you were doing like an update every frame, you wouldn't want to mess with doubles because they're a little bit slower. But yeah, that's pretty much it. Floats are just faster, but at the cost of precision. And they're just like an integer, they're 32 bits or 4 bytes to a float. Okay, so here's a little bit more variable syntax continued. So like we have a character, which is just a single letter, ASCII letter. So it can be a space, it can be a couple other things. And you designate that with single quotes. So we have just following this line, we have our character, which is the variable type. Then we have the identifier, which we're calling letter, and the value is D, which is a single character. And then we can have strings as well, which are just concatenation, like a group of characters. And then at the bottom here, we have some different accessor types, which are private and public. And really what that indicates is what other code can kind of see it. So if it's private, it means like only this class will be able to access it. If it's public, then it means other classes and other pieces of code can kind of access it. Or you can edit, in Unity specifically, you can edit this kind of stuff in the editor. So that's good to know. Versus like something like a social security number, you'd probably want to keep private and not have everybody have access to it. So yeah. And public variables are pretty much always written in Pascal case. It's good practice, though they don't have to be. Which is like at the bottom where every letter of the word is capitalized, like player score there too. So this one's a little bit different for our fun fact here. There are 8 bits or 1 byte to a character. It's the smallest that you can do in C# that I know of. And then for a string, if you wanted to figure out like how much data it's taking up, you just multiply the 8 bits for your character times however many characters are in the string. So just a little fun fact. Okay, so now we're getting to functions and methods, and this is more of the data flow part of things. So we have a declared method here in C#. So what this function does is it takes 2 integer values, a left value and a right value, and it adds them together, and then we're returning that value. So for example, that we have at the bottom, you would call this, if you say, I want to get some result, I want to add 2 and 3, well, I'm expecting 5, and what this code does is this just runs it through. So it says, okay, the left value is 2, the right value is 3, add those together, and give me back 5. And this is where like programming gets really powerful because you don't have to worry, or you don't have to keep rewriting your code. You just write it, parts of it once in a function, and then call the function, and it can go through and give you different results that you need for whatever your case is. So we'll break down some of the parts of this syntax. So we have a public variable, which is just an access modifier, just like variables. So can other classes, can other pieces of code call this function, which is what that's telling us. Then we have the return type, which right here is an integer because we expect it to give us back an integer, not like a string or a character. So that's that. Then we have the name of the function, which are usually Pascal case. And then we have our parameters here, which is what data flows into this method. So if you kind of like breaking this down, the return type is what flows out, the parameters are what flows in. And then, so let's do another example. So this is the another type of function, and we have some differences here from the last one, right? So we have a private keyword, which means that only things in this class, only things in this piece of code can call this. And we'll go over like what classes are in a minute, but so it's private is the difference. Void means it returns nothing, so it's not giving you any data back. And then it also has no parameters, right? So you can just call this function and we'll run whatever code is in there, and that's pretty much it. And then for here, for example, we have it calling a logging function in Unity, so it's saying like this is a test. And you can use that all the time for debugging your games. Okay, so I've been saying classes a lot. So the difference is with classes, it's pretty much all the things we just covered, except you can encapsulate that into an object, and then you can use that object to interact with other objects. So it's a way to kind of make your code a little bit easier for you to understand, and it also has a lot of other benefits which we're not going to dive into. But back when programming languages were started, we didn't really have object-oriented programming. It's kind of a semi-new thing, like last 20, 30 years. And a lot of programmers still prefer to not to use object-oriented programming. But it allows people to, conceptually makes it a little bit easier for beginners. And the encapsulation and some of the other stuff is a pretty useful tool for organizing your code and architecting it. So if you want to read more about that, there's inheritance and polymorphism and some more in-depth topics. Okay, so that's some of the nitty-gritty stuff. So I want to talk a little bit about, with Noah here, the turning a game design into a system implementation. So before you touch a computer, you should probably establish the design of your mechanic. And that means a couple different things. So the first part is you break down exactly what's supposed to happen and what your expected output is, kind of just like we were talking about with programming. You want to know what data goes in and what comes out, what result goes in, what comes out. And then you need to figure out some of these different factors and variables for tweaking and changing it, right? So a thing I usually do a lot is I get proposed a design at work, and then they say, okay, I want it to function this way. And I might say, okay, and then I go to start, and then I have to sit back and think about, okay, what exactly has to happen, or what's unclear from what they say. And then you just kind of keep asking questions until you understand the exact design intent of what's supposed to happen, and then from there you can kind of code and start to see how it all kind of translates into data and stuff like that. So an example I use a lot is I always say, oh, my designer comes to me, and then I have to program. And that's something I should mention is that sometimes you are the designer, right? So you get an idea in your head, and you go, okay, I want to program this, or I want to make this game. But it's a little ambiguous, and you haven't really thought it out all the way. So if Noah's my designer, and I come to him and I say, hey, Noah, I want to throw a ball into a hoop. Or, you're my programmer, I'm the designer. Okay, that's what I tell you.
Okay.
Okay.
Well, my first question is, how are we going to be throwing the ball?
I kind of want it to bounce off the walls, and then it does a circle and lands in the hoop.
Right. Okay. How's the player going to throw the? What kind of interaction are we looking
Oh, good question. I didn't really think about that, right? So here's some of the stuff we would have to consider. So you have to start physics. collision detection, rendering, input. These are just some of the things you need to think about with something even as simple as like throwing a ball into the hoop, right? It's just how you want it to do. And it's not all as complicated as it seems. It's just you need to kind of like flesh out exactly what your design is. So each of these can kind of break down into smaller variables and functions, right, that you can program out and make a prototype and a game out of. So some of the clarifying questions I had were like, is it 2D or 3D? Are we using sprites or models, which is kind of like 2D or 3D? What level of precision is needed? Like, is it an accurate basketball simulation where I'm like hooking it in and it needs to look just like in the NBA? Or is it like, something real gamey? What type of inputs are required? Am I doing it on a mobile phone? Am I doing it on a computer? Am I clicking it? And then a question I ask all the time when I get proposed a design is, can you walk me through this mechanic from start to finish? So in their own words, or in your own words, if you are the designer, it just is bare bones and as simple as you can, explain it to yourself or somebody else. Do you have anything else to add to that, Noah?
I think that's good.
Cool. So from here, we're going to move on to the workshop section of it, and we're actually going to fire up Unity, and Noah's going to walk you guys through that.
Yep.
Great.
Cool. So before we get going, there's going to be a little bit of setup. The stream said it was a little quiet, so I'll bring them up. Let's see here. Oh, that won't do. And so as we go, oh, that's the wrong one. As we go, they removed that menu, didn't they? This is gonna take me to the wrong spot anyways. It's this, no, still not. There we go. Windows. Okay. As we go, if you have any clarifying questions, like I don't want to run 30 minutes past when there was a relevant question, so feel free to shoot up a hand or anything if you have any questions. Sam's going to be watching the stream chat, so.
I don't see any chats at all, but hopefully if someone
Yeah.
does something.
It should pop up over there. I'll also try to remember to pop back over and look at the chat. This should do the trick, I hope. All right, so hopefully that's better for our stream. Yeah, it looks like it's doing something. I hope I didn't just blow out everybody's ears.
Yelling.
Oh no. All right, so yeah, hopefully that helps a bit. Cool. So we're gonna go ahead. I already have the project open, but if you have just downloaded the project and you've just opened Unity, I don't know if they force you to go through Unity Hub like by default now. If you manage to download the editor without the hub, it's just File and then Open Project. Oh, and look, it takes me to the hub. Well, anyways, if through the Unity Hub, if you hit Open, it says select a project, and that's actually just a folder. So for example, I have this project here. I can go and select RGD Unity Intro here, and then just hit Select Folder. And then it will open that for me. And it says it's already open. But that's the flow, so give everybody a chance to get that open.
You gonna go over the inspector stuff too?
As we go, I'm going to try to like kind of...
Gotcha.
So there's a lot with Unity, and way more than I could cover in one workshop. So I'm going to try to really kind of hit what is relevant to what we're making, and then this is kind of designed to touch on a lot of different points and touch a bunch of different parts of Unity. So hopefully it will give you a good overview, but there's a lot more that you can dive in on. So yeah, like Dakota said, our broad question is our broad design is we want to throw a ball into a hoop. So how do we go from what we have right now, which is just a blue screen, to throwing a ball into a hoop? Well, first we should get acquainted with our tools. In Unity, everything that happens in a game is contained within what is called a scene, and that's kind of like, or in sets of scenes, right? So that's where anything that's happening on the screen is happening inside of a scene, or multiple scenes, but we won't talk about that. By default, the default layout is on the left side of the screen, you'll see what is called the hierarchy window, and that shows what the current scene is and then the contents of the scene. And right now we just have a camera, right? So that's the sorry, that's the hierarchy. In the middle, you have the game view and the scene view. So the scene view shows you like kind of what's under the hood happening in the scene. It shows you the objects in the scene, which is right now just the main camera. Whereas the game view shows you the actual game being rendered by the camera. Because the camera you can see over here in the inspector, where you set basically properties for objects in your scene, you can see that the background is blue, and so that's why we see a blue screen. If I changed it to like kind of like a different type of color here, some kind of like, I want sky blue, maybe something like that. If I click on it and then change the color, you can see that the color changes in the game view.
And these are all just variables on the back end like we were talking about.
Yeah.
Yeah.
At the top, you have your play button, your pause button, and your next scene, your step button. I'm sorry, I always think that's the next scene button. When you're paused, it steps you through frames. I rarely use it for whatever reason, but it's there. That's the basic layout. Oh, and at the bottom you have the project view, which shows you the folders in your project. This will be useful pretty much immediately. And the console, which shows the output from your scripts, which will also be useful.
So also that debug log I showed earlier, that would show up in the console as well.
Yeah, so the debug log line would show up there. Like I said, we'll kind of touch on a little bit of everything here as we go, and so it'll become more familiar as we go.
Yep.
Cool. So I'm going to try to quickly, like broadly define, if we want to throw a ball into a hoop, what are some things that we need to accomplish that? We're going to need a ball with physics displayed on the screen. We're going to need the ground, because otherwise the ball would just fall right off the screen, right? We're going to need some kind of way for the player to actually throw the ball, some kind of interaction. This is when I'm implementing a design, I always start from the point of interaction, because that's like, for me, the fundamental part that needs to feel right before I move on. So we get there early. We're going to need some walls to constrain the ball, because once the player can start throwing it, they're going to throw it out of the map, and then that's lame. We're going to need a net for the ball to go into with some kind of physics as well. Then we get into the tricky stuff, which is we're going to need a way for the net to know that the ball went into it. And then we want to keep track of score, because you don't want to just throw a ball into a net and be like, okay, that happened, but it's a game. You're not supposed to keep track of the score yourself. That's lame. So let's start with the ball with physics. I'm going to go ahead and I want my mouse for this. I'm going to create a folder down here in the project view. And I'm going to go ahead and create a folder. And I'm going to name this Sprites. All right. So we got this folder down here named Sprites. If I double click it, I can navigate into the folder. And then I'm going to go ahead and right click and hit Show in Explorer, just so that I can get back to the starter project root folder, because in there we have this starter assets folder. And this is something I included myself. This isn't a Unity folder, but this is just kind of the assets that we're going to be working with. So it's probably best just keep this window pulled up. We're going to be coming back to this to pull in stuff. These are all just like some Creative Commons public use stuff I pulled from the internet. But we're concerned with the basketball right now. So in Unity, there's a number of different ways to import assets. In this case, we're just going to go ahead and drag this right in to the Sprites folder. And now we have the basketball right here in the Sprites folder. If we click on it, we can see in the inspector all of its different properties of this actual Sprite asset. Most of this is not super, most of it is out of the scope for this project. But there is one thing that we will touch on in a second. So let's go ahead, now that we have the sprite down here, let's just go ahead and drag it right into our scene. So go into the scene view, and then just drag it right in. And so now if we go back to the game view, that's a big basketball. That's maybe a little bit bigger than we want. And so there's a number of options that we have to make it smaller. Some people may change the scale and say, oh, I want the basketball to be 0.3 by 0.3, right? And then it's smaller. However, because the basketball is kind of like the key element in our game, and we want everything to be scaled relative to it. I don't want the basketball, the first thing that I do is scale it down, right? So another thing we can do is we can actually change the size in Unity units, which is what I was changing there when I said it was 0.3. I was making it 0.3 Unity units. We can actually change the size of the ball in Unity units by changing its pixel per unit value. Pixel per unit is basically saying for every pixel, every n pixels in the sprite need to convert to 1 Unity unit. So right now it's 100. And we can see down at the bottom here, we have 340 by 340. So this ball is about 3.4 Unity units across and tall. Now, the convention is kind of just, it should be 1 Unity unit to a meter, roughly. That's what most people would base it off of. It depends. For our case, I'm going to go ahead. I played around with this ahead of time. I kind of cheated. This is pulling the thing out of the oven, basically. I am going to go ahead and set it to 340 PPU.
And while he's doing that, I just want to mention, if you are an artist, this is like super crucial, because if you're designing assets of a specific resolution, like this one's 340 by 340, then you can kind of consistently set the PPU for all of your assets across the board.
Generally, we're going to be kind of just constantly setting things because I'm just pulling stuff from the internet and it's in various resolutions. Generally, you don't want to have to be playing with PPU that often. If you find yourself doing that, there might be a problem in your workflow that you want to fix. So we're going to go ahead, and once we set that value, you can just hit apply down here at the bottom, and then that'll actually apply it to the object, and now we have a smaller basketball here. So great. So now we're going to have to add a collider to it. So we're going to have to give it some physics. So go ahead and select the basketball over here in the hierarchy. If you don't see anything in your hierarchy right now, it looks maybe like this. There's just a little caret next to the main scene, and you can just click that caret to open it up. So with your basketball selected, when we go to the scene view, and look here at this basketball, we're going to go ahead and in the inspector, click Add Component. And the Add Component menu allows you to add any number of Unity built-in components as well as your own scripts. So we're going to go ahead and add a circle collider. So what components are they're kind of like, what's the good analogy for the component model? There's a good one, I can't remember. It's like you're plugging in a bunch of different things to an object, right? Like say you take like a potato, right? And you put googly eyes on it. And well, now you kind of have somewhat of a face, and you put like Mr. Potato lips, and like, great, now I have a Mr. Potato. But it's a sum of many parts. In the same way, to get a basketball that's just an image on the screen to actually do something, you're going to have to add other parts to it.
And they're also not just visual or just physics or anything. I mean, this is a number of things, from rendering to scripting, which is like gameplay and things. All those in Unity are driven by component systems.
Exactly. So now we can see that with the green circle around here, that kind of indicates to us that there's a collider on it, right? But you can see that the green circle is actually a little bit outside of the sprite. So one thing we can do is we can actually play with the radius value here. So I'm gonna hold Alt, and if I hover over the radius label, you can see that the little arrows pop up on my cursor there. So I can actually click and drag. And I'm holding Alt because it gives you a little bit increased precision. If I let go of Alt, it would just be a little bit faster. But I'm going to hold Alt and then just kind of zoom it down until it's roughly, oh Lord, I missed it. Roughly inside just barely inside. So now the basketball is fit pretty well to its collider. Generally the convention is, especially when it comes to when you have like a model for a player, put the collider just a little bit inside. It just feels better. It makes players happier. For example, like if you had bullets flying at you and one just nicked the top of your head, you'd be real sad if that caused a death. Instead, you just feel like it's a near miss if the collider is just inside. This is a little trick. So if you couldn't quite get it, the value we have here is 0.44. So now let's go ahead and test our game real quick. Let's just see what happens. So I'm going to go over to the game view. I'm going to hit play. Hooray! The basketball is just on the screen, not moving. The reason being is we have a collider, but we don't actually have any like physical body on this basketball. So another thing you're going to need to add is a rigid body. And so a rigid body in Unity is basically anything that has physical motion, interacts with the physical world and other bodies in the world, and other static colliders, which is what our basketball was before I added this. So we have a rigid body on it. Again, there's a bunch of properties on here that are mostly out of the scope for this workshop.
Though if you've taken physics, some of these might look familiar.
Yeah.
Such as, can't read it.
Mass and linear and
drag,
yeah.
Angular drag and stuff like that.
Yeah. But for our case, actually the default pretty much is fine. So if we go ahead and hit play now. Hooray! The basketball is gone. This is why we need a ground, right? Cool. So that's super exciting, right? We've almost got the game done, basically. Let's go ahead and add some ground now. So we're actually going to do some kind of a programmer's trick that Unity's built for us. Instead of bringing in an asset for this one from our assets folder, we're actually going to create what I like to call the source pixel, which is if you go into the create menu, right-click in your project view and create, Unity's made this nice built-in feature where you can actually make sprites that are blank. And so I just want a square here. And I'm going to call it source pixel because I love my source pixel. Square is too boring. So it just creates a quick sprite for me. By default, it's 4x4 or 2x2 pixels. So, oh, I'm sorry, it's actually 4x4. It's 4x4 pixels, so it's just a little tiny little something there. But we can do a lot of really quick mocking up or blocking out of stuff with our nice little 4x4 source pixel. I call it source pixel because I used to, before they made this menu, you could just go into any old image editor and export a 1x1 pixel, and it's the same effect. So we're going to go ahead and drag source pixel now up into our scene. And now we have source pixel in our scene. The naming for that, maybe not the best though, because I don't know, I don't think we want to leave it source pixel for the rest of the game. It's same like in Photoshop, if anyone's ever worked with that, where you want to name your layers. You don't want like layer 1, layer 2, layer 3. Like it gets hard to work with a lot of stuff, with a lot of moving parts. So I'm going to go ahead over here in the inspector. You can see at the top it says source pixel, and that's a little text field you can click on. I'm going to go ahead and click there, and then type in ground. Sweet, so that renames it. You can see in the hierarchy it changes. Another way you can rename things is just by clicking once and then clicking again and kind of waiting, and then it pops up. You got ground there. And then the third sneaky option, number 3, is F2 also brings it up. Cool. So this doesn't look much like ground right now. So first of all, we got to get this kind of positioned correctly. What I'm going to do, I'm already in it. But actually, I'm going to start by, I'm going to click on the move tool up here and grab this green handle so I can move my ground up and down. I'm going to move it down so it's kind of hanging off the bottom of the camera there. And now I'm going to select the scale tool here up in the corner. And I'm going to grab the red handle and pull on that to kind of scale this thing out.
So unlike before with the basketball, where we were changing the pixels per unit, we haven't changed that 4x4 pixel. We're just scaling it out in the Unity units here.
Right, and conveniently, because it's just a white asset, you're not going to see any stretching or anything that looks weird. If we do that to the basketball, that's not what you want. It's not at all. But luckily, since we just have this nice white background here, this is fine. Next thing I'm going to do, this doesn't look much like ground, like I said. I like to add a little bit of splash of color, something. So I'm just going to click over here in the inspector. Sorry, I'm moving a little quick. Click over in the inspector, select the sprite renderer, select the color property, and then this dialog comes up. You can click and drag around in here and change the colors however you want. I'm going to go with something kind of brownish. Won't spend too much time on this because we started a little late, but that's fine. So now we've got ground. Last thing we're going to want to do is we're going to go over here in the inspector again, add component, and box collider 2D. So this time, instead of a circle collider, we're adding a box collider to the ground. Go ahead and add that. Pops right on, and you can see it's the box collider actually snapped exactly to the sprite, conveniently because we're using a square sprite, and it can detect the bounds of the object that it's on. Sometimes you'll have to do a little bit of tweaking by changing these values, the offset and size here, but or by selecting edit collider and then dragging things around. But luckily for us, we don't have to. So now, let's go ahead. I'm going to go ahead and hit Control S now. It's a good habit in general in any software to save all the time, especially before you run. And then I'm going to hit play. Now I'll tell you what, that looks like a basketball. That's exactly how I expected it to react.
Do we need a rigid body on the ground?
We don't need a rigid body on the ground. Great question, Dakota. Because the ground isn't moving, it doesn't have to interact with the physical world other than be a static element. It doesn't need a rigid body. Now let's say we added one, just for curiosity's sake. As you would expect, both of them just fall off the screen. And so now they're enjoying a fun journey down off the screen. So you got to be careful of that. Static bodies generally don't need a rigid body. There's cases where they do. But generally, just a box collider will do. And other rigid bodies will interact with it. Cool. So like I sarcastically remarked, this looks exactly like a basketball and certainly needs no changes. So we're definitely not going to make any changes. I got a little too deep on that, but we're gonna make the basketball's physics a little bit better. So the biggest thing we're missing, right, is it doesn't bounce like you would expect. Like it just kind of thunks on the ground and sits there. So this is just how the default Unity physics setup behaves. Is it has no bounciness and a little bit of friction. You can see here in the circle collider on the basketball that I got selected in the hierarchy here, it says material none. And so colliders in Unity can have what's called a physics material, which defines its bounciness and its friction. By default, like I said, it just has a little bit of friction and no bounciness, but you can create a new physics material. I'm just going to go ahead and dump it here in the main assets folder, but you could put it in a subfolder called maybe physics materials or something. It's good to have your folders organized better than I'll do for this demo. So you want to go into right-click Create, and then Physics Material 2D. Be sure you're selecting 2D for this stuff since we're working in a 2D environment. You have to, the 3D engine and the 2D engine aren't particularly compatible, so I couldn't create a 3D physics material and use it. Create a 2D one. We'll give this the name of basketball. And so you can see now in the inspector we have exactly two values. It's a pretty simple thing. You have friction and bounciness. We'll keep the friction the same for now, but we're going to set bounciness to 0.8. So this is a range between 0 and 1. I don't believe you can set it higher than 1. If you can.
Does anything if you can.
Yeah, if you can. Well, it might just bounce back more. So, basically, it's a percentage value between 0 and 1, and then it's, so it's like 0 being 0% and 1 being 100%.
And you had something to point out, though, is, in your own projects and stuff, feel free to play around with this.
Yeah, for sure.
No, you got a question?
Oh, yeah.
If you set the bounciness higher than 1, will it just go off into space? Like, does it bounce higher than where it dropped from?
So if you set the bounciness, let's just try it. So if you set the bounciness higher than 1, let's say 1.5, my theory, and this is the great thing about computer science, is having fun testing these types of things. My theory is that it'll come back up 150% of what it hit with, right? So we'll go ahead and attach this and we'll test it. So I selected the basketball in the hierarchy, and I'm actually going to attach it in a different way than I think we have in the past. I'm going to click here. There's like a little dot on the side of this field, and if I click it, it brings up a menu for me, so I can go ahead and select basketball here. Cool. These menus are really nice because they actually filter by the type that they're expecting. So I don't get all of my assets folder. I just get the one relevant asset, and it's searchable if I have more than one. So now if we go ahead and hit run, let's see what our 1.5 bounciness basketball does. Right, so it bounces back up with a little bit more, and a little bit more. Oh, where are we at? Oh gosh. Let's zoom out a little. Oh geez, we've already gotten pretty far. Cool, so yeah, that's what you'll get. In our case, I think just 0.8 will be fine. So let's go ahead and set that. And now, looks a little bit closer to a basketball.
Notice how that, because it's less than 1, it's also diminishing here, versus before it was getting bigger and higher and higher and higher.
Right, yeah, so because it's less than 1, it's diminishing. It's coming back at 80% of its original force.
Which is more like what you would expect with
Yeah.
real life basketball.
So if you were to set it to 1, would it just bounce to the exact height that it dropped from and just keep doing it over and over?
Right, yeah, so if it was 1, it would just keep going back to where it was. So if we look, it's right about there, and right back up. And it'll just do that forever. Yeah, so it'll just keep bouncing infinitely. I'm gonna go ahead and set that back to 0.8. Oh. And we'll move on. Cool. So it bounces now. That's awesome. We're even closer. So, yeah, what's up?
Is there, when you set it below 1, does Unity have like a minimal amount that it can bounce so that it'll eventually stop and not just continue bouncing to like infinitesimal amounts?
So I don't think you can set it. The question was if you set can you set it to below 1, and what does that do? It doesn't. You can't set it below 1. It's limited at 0. So it can have the lowest value is just 0 bounciness.
Though programmatically, you could probably play with some of this stuff and
Yeah.
change the values around.
Yeah, that's some. I've never even tried that. So it's maybe something to play around with.
But I mean, my question was, since it's 0.8, at a certain point it'll stop bouncing.
Oh yeah, I'm sorry. Yes, when you set it below 1, it will eventually stop bouncing. Yeah, it gets to like infinitely small, and then eventually, I think they just kind of cut off the
Yeah,
bouncing.
it actually sleeps the rigid body, so the rigid body stops all of its motion after a certain threshold.
Yep.
And you can play with that kind of stuff.
What's up?
This is kind of more on topic, but have you ever added the camera as a child of the objects that is moving?
So the question was, have you ever added the camera as a child of the objects moving? Yes, and it, depending on your application, can be really great or really bad.
It's pretty common in top-down games a lot of the time.
Yep.
But usually, if you directly parent it, it's going to be moving like exactly with your player, and you won't really get the effect you're looking for. Usually, you have like a damp behind it, so like the player moves up, and then the camera kind of slowly follows behind. Different things like that.
Cool. So we're going to move on to our first script. So this is really where we're getting into the meat of things. So by convention, pretty much everyone has a scripts folder in their project view. That's where they would put all their scripts. So, and subfolders, but we won't get into all that. So we're going to create a new folder down here in the project view called scripts. And then we'll double click to go into that. Now we're going to go ahead and right click again, create C# script. And we're going to go ahead and call that basketball. So what we're getting to now is, we have the basketball on the screen, we have ground, we need some way for the player to interact with the ball now. So I'm going to go ahead and double click this because Visual Studio sometimes takes a little bit extra time to open up.
So Visual Studio is the interactive development environment, which we're using here. Though Unity also has Mono built in still.
I think just for Mac now.
Oh,
I think Mono develops just for Mac, yeah.
But this is just a way to organize your code, and it does some formatting and highlighting, so it's easier for you to read it.
Yeah, and you might notice mine looks a little bit different than what you're seeing. I have some other extensions installed because I spend literally my life in here. What's up?
Is there a major difference between MonoDevelop and Visual Studio?
I think there's in part a preference difference. Some people prefer the environment one over the other. I would say I think that the IntelliSense and autocomplete in Visual Studio is better, and there is generally more support for like a broader range of programming operations, like higher level stuff, like refactoring and stuff. But it really, any tool is fine.
It's also maintained by Microsoft, so you have a lot of that support there too.
Right, exactly, yep. Cool. So this is the default Unity script. You'll know anything that has this like colon mono behavior next to it, that just says this can be a component, right? This is a normal Unity script. It can be a component. Basically, what's going on here is this basketball is an object that is inheriting from the mono behavior object. We won't go too deep into the object-oriented programming side of things, but just know this means this can be a component in Unity. Then within it, we have two functions that are added by default by Unity. So because Unity kind of uses C# but also kind of has its own, because it's called scripting because it's kind of its own layer of interpretation on top, right? So Unity has a bunch of default functions that do specific special things and have specific special meanings within the engine. For example, start, like it says here, is called before the first update, basically when an object comes into existence or is activated. Update is called once per frame, so this is always called every frame, and this is where you can do kind of some of your movement or whatever code. So generally start would be used for like initializing stuff, and then update would be used for updating stuff.
And Unity also is handling a lot of the nitty-gritty stuff for you. So what this is doing is it's per frame is usually most games run 60 frames per second, but it's also not consistent across computers. So what this is doing is kind of saying, okay, well, whenever we get that update, here's the code that you want to run.
Right. Cool. And so there's a bunch more functions, and we'll touch on a couple, but you'll have to do a little bit of your own research to get all of them. In our case, we're going to go ahead and actually add another function that Unity has built in called on mouse down. So we want when the player clicks and drags on the ball for them to be able to kind of click and drag and then create a force that will be used to push the ball and throw it in a direction, right? That's our core interaction. So Unity has some functions that actually help us handle when a object is clicked on and when it's when the mouse is released. So on mouse down, I'm going to go ahead and type it out all the way. I usually rely on autocomplete for this type of thing. So we say void on mouse down. Oh, and then autocomplete gave the rest of it to me. But you want these parentheses here, and then opening and closing braces. So the parentheses, like Dakota said, that's where parameters would be if there were any for this function. And then inside the braces is the contents of the function.
And it also doesn't return anything, and it's private, right? So some other class can't call this this on mouse down function.
So this is called when the player clicks on an object. And specifically the object that this component is attached to. So just to kind of demonstrate this in action, we're going to go ahead and say debug.log mouse down. Go ahead and save that. So on mouse down, when the player clicks on the object, it's going to log mouse down. So go in here and run this. And so this debug log will come out in our console, and we're going to go ahead and click on the basketball. And nothing happens because common, easy mistake to make, we didn't attach our script that we just made to our object. That's a very easy pitfall. I've done it a million times. Going in and like writing this whole complex thing and then going to run it and being like, why doesn't it work? Probably forgot in all of your time spent in the IDE that you have to continue working in Unity. What's the question? Oh, thank you. Yep. Yeah, so we want to select the basketball. Oh, there we go. We want to select the basketball. We're going to go ahead and add. And now, so we add component. Now we can search basketball. and we see our script here. And you can see it has the little script icon that matches the project view. Click on that there. There's no properties to the script because we haven't exposed anything publicly. We'll get to that in a second. But now, click on the basketball, and you can see down there in the log, it says mouse down. Every time I click on it, we get a new one.
At the bottom, it also shows you the call stack, which just means shows you what script it was called from and stuff like that.
Right.
So that can be helpful.
A little more debugging info down here.
Yeah.
Cool. I'm going to go ahead because we're going to be doing a little bit more of this type of thing, and I don't want to clog up my console with a bunch of this type of situation. There's a option to collapse all the messages of the same, just the same message in the console. So I'm going to go ahead and click collapse, and now we see mouse down and 20. So it gives me a count, and that number will go up instead of my console getting all clogged up. That's a nice little trick. Great. So we have mouse down. Something we'll also need. Oh, sorry.
Anytime you stop running your game mode, does the console clear for the next time you run it?
Right. So the question was, when you stop running the game, does the console clear? There's a clear on play right next to collapse. When it's highlighted like that, that means when I run the game again, then it'll clear. So it clears not after you stop running, but actually when you start the next instance, unless you turn off clear on play. Good question. All right, so now we're going to add private void on mouse up, because we're going to need this information as well, because we want to know when the player clicks down and lets go. In the same vein, we're going to add debug.log mouse up. So now we're saying log the message mouse up when the mouse goes up. Save our scene. And this time we don't have to do anything in Unity other than click run because the component's already attached. So if we go ahead and hit play and click down and up, down and up, down and up, there we go. You can see I click down, it says 5 there, and I click up, it says 6. If I go ahead and hit clear real quick over here in the corner, oops, and then I click down and hold, it's not until I let go that it comes up. So now we know when the player's holding down, and we know when they're letting go. I'm going to try to pick up the pace just a little bit since we started late. Let me know if I'm going too fast though. Cool. So what we're going to want to do is we want to throw the ball by applying a force to the rigid body relative to the distance between where the mouse clicked down and where it released, right? So the mouse is clicked down at one point, the player drags to another point, and then releases. And that distance and angle would be the same force that's applied to the basketball. So there's a number of different components to this problem that we have. We need to know on mouse down where the mouse was, or where the mouse is when it comes down. And then in on mouse up, we'll need to know that value plus where the mouse currently is. And then we'll calculate the force from there. So, let me see here. Oh, I actually did decide to implement it slightly different. Sometimes I come up with different solutions later. What we're actually going to do is get the position the mouse was released at and then apply a force relative to where the basketball currently is. This is actually better because then the player expects, right, if the basketball is moving around on the screen, then it will apply the force relative to where it was currently. But we will fix the issue of it moving later on. So on mouse up, we're going to want to get the mouse position from input. So input is a way to get various means of input, like keys being pressed, mouse buttons being pressed, and other things at any point in your code. So you just type input dot get or mouse position, right? Yeah. And so input dot mouse position. In Unity, like Dakota said, it's best to use for public variables Pascal case. Unity doesn't always do that. So in this case, we're actually going to do lowercase m for mouse position, even though this is technically a public property.
And notice in Visual Studio, IntelliSense is kind of like telling you what that is if you didn't know. However, they had implemented it, they wrote a tooltip for you.
Right.
So.
Yeah, so this is the current mouse position in pixel coordinates. That's important to know because pixel coordinates are not the same as Unity units. And we'll talk about how to convert. So we're going to want to store that. So we'll say vector2. That's what the type that we're getting from mouse position is. Just an x and y point. Mouse pos equals input.mouse position. Oop. There we go. It's actually a vector3, but it'll convert just fine. We don't care about the 3 is the z component, and we don't care about the z component in a 2D application. What was the question?
Is mouse position a method?
Mouse position is a property, so it's effectively, in this case, an attribute or a variable. But the difference between a property and a variable is a property has underlying functions that it calls in order to get the value, but it appears as if it's a variable.
Yeah, and Unity is doing this for you on the back end. So
Right.
They're just tracking all this.
Right. So this, as far as like Unity sets a value somewhere else, you don't have to care where. That's the nice thing about Unity is it does a lot of stuff for you in this case. You just know reliably this will always be the mouse's position in pixel coordinates. Cool. So right now we have it in world position, or in screen position. So we want to convert it to world coordinates. And luckily, we can do that through the camera with a convenient helper function called camera.main. So we're going to go ahead and set mouse pos equal to, so we're reassigning the mouse position vector, camera.main. So this is the main camera in the scene, dot screen to world point. You see this function that's being recommended here for me in autocomplete. It's a really bad, I shouldn't say bad habit, but it's a really strong habit to just go ahead and do that. But I'll try to type it out so we can see the whole thing. There you go, screen to world point. And that expects, you can see thanks to Visual Studio showing the tooltip, it expects a vector3 position. And we're just going to go ahead and give it the mouse pos. There you go. So now we're saying, get the mouse position, please convert it to a world point, and assign it back to the same variable we used. That's just kind of nice for using the same variable. We could have defined a new one if we wanted. Is there a question?
So it turns mouse pos from vector 2 to vector 3.
Oh yeah, so this is kind of confusing. It's screen to world point does return a vector3, but vector3s have what is called an implicit conversion to a vector2, which means it just drops the z value of the vector3 and gives you back a vector2. So we can say here, since the compiler and since Unity knows that we're working with a vector2, it just knows to drop the z value for us. You could make this a vector3 and it would effectively work the same because nowhere when we're working is the z value going to matter. But yeah, that's a good catch. It is returning a vector3, but anywhere that there's a vector3, you can put a vector2 and it either adds a 0 z value when it needs to be a vector3, and when it needs to be a vector2, it just takes the z value off. And so they effectively work the same. Cool. So now we have the mouse position in world coordinates. We need to calculate the vector from the mouse position to the ball. And I don't have time, unfortunately, to teach a vector math course, but effectively when you subtract one vector from another vector, it is the resulting vector is the right-hand side to the left-hand side. So if we want a vector from the mouse to the ball's position, we want, so let's say mouse to ball. We say transform.position. So transform is a variable that we have in any script that refers to the object it's attached to. And the transform holds the XY position, the XYZ position, as well as the rotation and the scale and all sorts of different things. Transform to position minus mouse pause. We're going to get an error here because this is one case where the implicit conversion is a little weird. The compiler gets confused because it could possibly be a vector 2 minus a vector 2, or a vector 3 minus a vector 2, or a vector 3 minus a vector. There's many interpretations it could take. And we can just say parentheses vector 2, give it a little help, and basically say, hey, turn this one into a vector 2, and then do the math.
It's important to note that this vector also has a direction here. So if Noah is the transformed out position, I am the mouse position, it's getting the vector this way, right? Or
Yeah, to me. Yep.
So from me to him,
Yep.
this is how your vector is going.
Yeah, like I said, I always get these confused, and I'm really worried that I've gotten it wrong, but this is why I did it ahead of time. It is the right-hand side to the left-hand side, which is kind of counterintuitive. But the nice thing is now we have in world coordinates a vector pointing from the mouse to the ball. And if we apply that as a force on the ball, that will be exactly the direction we want it to be going. So now we're going to say, we're going to call a helper function called getComponent. And so unlike transform, which is baked into every object in Unity, we can't guarantee that there's any component of any type. So we can't just say like, there used to be a variable called rigid body, but we can't just say that anymore. We actually have to call a function to try and find it attached to the object. So the rigid body, since we had to attach it in the editor, we say get component, and then we put in these kind of like sharp angle braces here the type of component we want to get. In this case, we want a rigid body. And again, be careful that you're putting 2D here because we're working in the 2D space. So this is a function. This is what's called a type parameter. It's just a different kind of parameter, and it goes in angle braces. And then our regular parentheses, and then dot add force. So we're saying on the rigid body component, we're going to call the add force function. And now, finally, we get to provide a vector 2 instead of a vector 3 for once. Unity is interesting because it's a 3D engine that had a 2D environment kind of slapped on top, and some parts of the Unity API are still vector 3s, even though you can work with them as vector 2s. So mouse 2, and they can trip you up sometimes. Sometimes things behave very weirdly between vector 3 and vector 2.
They also have some uses too, for scaling and stuff, how you would move a 2D sprite in 3D space.
Right, yeah, they are still helpful even when you're working in 2D, for sure. There's a question?
So moving the rigid body 2D makes the whole object move. You don't have to call it specifically like this object is moving this way.
Right, so the question is moving the component makes the whole object move? Yeah, so the component acts on the object in the same way that our script can act on the object. They're all acting on the same thing. And we could say, if we wanted to, right, we could refer to ourselves by saying this.getComponent, right? That's in C#, that's implicit when you're working within the same class, because this function is coming from mono behavior, so it's effectively within this object.
Yep, and then the rigid body is its own object, so that's why we use the dot, because it's saying we're calling another.
Yes, exactly. But we all are part of the same whole.
Yep.
Cool. So we're going to go ahead and save that. And I think we're ready to test. So let's go in here. Hopefully I've done everything right. I kind of didn't really look at my notes, but that's okay. Go in here, click on the ball. Now I'm going to drag it a little bit over here and then release. And oh, it's rolling a little bit. Let's maybe try a little bit bigger. Okay. This is, it's something, I guess. So we can kind of roll the ball around if we want. We can't really throw it up at all if I click and drag real far. But we can roll it. That's a step in the right direction. So it's kind of weak. And this is something you encounter all the time is, you want a result and you want to be able to mutate how strong that result is. So we're going to multiply it by a variable that's exposed in the editor so we can play with the value, right? As designers, we want to be able to have a bunch of tools to be able to play with and a bunch of numbers to change. Designers love numbers. So what we're going to do is at the top here, we're going to go ahead and add a little bit of space. It's just convention to put your variables at the top of a class. And we're going to make a public float. We're going to call it throw force, right? And we'll give it a default value. So this is the value it will appear as in the editor of, let's just say 1. So we've given it public throw force 1.
You're missing your F.
You don't need one.
I said you did.
So
It's good practice.
yeah, it is good practice.
Unity, sometimes can ignore that.
Okay.
Regular C sharp, I think it gives you.
I think it's implicit.
Is it?
Yeah. So Dakota said I'm missing my F. Normally float literals, which is what I have here. This is an integer literal because it doesn't have an F. If I add an F, that just tells the compiler, hi, this is a float. You don't have to do any conversions. By default, and don't quote me on this, but by default, I believe the compiler actually does decide that it's a float because it's being typed as a float in the variable, and then it converts it for you. But you can put the F here. So now if we go back to the editor, we have our basketball selected. And look, our throw force variable popped up here. I'm going to go ahead and move this script up a little bit just so we can see it a little bit better. So we got our throw force here, and it's just set to 1 for now because that was the default value we gave it. So now we're going to go back down, and in our add force call, instead of just adding mouse to ball, you can multiply any vector by a scalar value or by a float value, right? And you will get that it'll just make the vector longer, right? It'll be multiplied against its magnitude. So if we multiply throw force with the little star there, for the record, what this does now is it says add a force that is mouse to ball multiplied by, with this little operator here, throw force. And since throw force is 1 right now, that doesn't make any difference. But if we go in here, let's go ahead and play. So a cool feature in Unity is you can actually, once you hit play, anything you changed in the inspector, nearly anything, little asterisk there, but anything you changed in the inspector will actually reset when you stop playing. So I can set throw force all over the place and play around and try different values, but when I stop playing, they reset. It's both a blessing and a curse because sometimes you can like spend hours trying to get something just right and then you forget that you were running and you're like, oh no, this is terrible. But it's also a blessing because say I set throw force to 1,000,000 and then that breaks the game and I'm like, okay, just forget it. Just keep in mind. So we're going to play with it and set the force around and see how we feel about it. So let's try bringing it up to like 5-ish. We'll click and drag and still not really getting a whole lot of anything. We'll try something a little bit better. So let's say, I'll try 50, just multiply by 10 when in doubt, right? So let's click and drag. Okay, it's not so bad. That's like kind of like a basketball situation going on now. I think it could still be better though. I think, certainly not looking at my notes at all. Actually, it's much lower in here. Oh well, let's set it to, I think we're kind of frame rate locked right now because I'm streaming, but let's just go ahead and set it to 100 and call it a day. I think something, see, I did it to myself. I stopped running and then it didn't work. Let's set throw force to 100 and see what it ends up being like. Let's see here. That's pretty good. I'll take that. All right, so one thing you'll notice is sometimes I click and drag and then it kind of like doesn't really do what you expect, like it only bumps a little bit. That's because it has a downward velocity when the force is applied, right? And so the ball is, I'm adding a force, but it's only so much, right? Oh, I think I know actually why our force had to be so big. In Unity, when you're adding a force, there's a number of different ways to add it. And you can kind of change what force mode you're throwing with or you're applying with by changing the force mode 2D enum, so you just say, you add a comma to your add force function, an additional parameter, force mode, which is optional. There's force, which means it adds a force to the rigid body, taking its mass into account. And then impulse, it adds a force impulse, which in 3D doesn't take into account the mass, but in 2D does. It's kind of a weird thing. But impulse basically is for used when you're doing things like this, where you're actually like throwing something, right? You're adding an impulse force to it. You're not adding a sustained force to move something. So now 100 might be a little extreme in impulse mode. Let's find out. Yep, it's gone. So now, using my trusty old notes, I'm going to set it to 3 and see what that does. Much better. Okay, so now we have it behaving as if it were in 100, but this time it's 3. Cool. So, great. So we're going to go ahead and let's freeze the ball when the player clicks on it, because I don't think it should move around. It's like kind of hard to control, right? It doesn't feel good. When we're playing with it, we can see that there's an identifiable problem. The other identifiable problem was that the force was kind of like getting applied against the velocity of the ball as it was moving. So we're going to freeze the ball, but we're also going to set the velocity to 0 before we throw it. So we're just going to stop the velocity and throw it. So this time on mouse down, we're going to want to do 2 things. We're going to say get component rigid body 2D dot, I think I actually do simulated. So simulated is whether or not the physics are simulated, equals false. So we're setting the simulated variable to false in the rigid body. And then get component rigid body 2D dot velocity equals vector2 dot 0. So this is just a helper function or a helper variable that just says give me a 0 vector so x and y are 0 and the magnitude is 0. Great. So now give everybody a second longer to look at that because I realized I typed it kind of quick. We're going to go back. And it freezes when we click. And then, doesn't unfreeze. So we may have set it simulated to false and the velocity is 0 here, but on mouse up, before we try to move it, maybe we should get component rigid body dot simulated equals true. So turn it back on. And now freezes in space, click and drag, and we can throw the ball. And now we've thrown it off the screen, which takes us to our next point. We're going to need some walls. In the interest of time, I was going to do a little bit of, talk about some different sprite rendering modes, but we're going to kind of cheat the clock a little bit. I'm just going to duplicate my ground object twice to make 2 different, or actually I'm just going to duplicate it once, make 1 wall, and then make the other one. So to duplicate an object, there's a number of different ways to do it. I'm actually going to hit Control D with the ground object selected. So Control D will give me another one in the editor, or the hierarchy, and then I'm going to rename it to wall. And I'm going to press the box. I can't remember actually what this is. It's a rect tool. That's right, rect tool. And this allows me, it gives me handles that I can grab. So it's like a transform tool in Photoshop. So I'm going to grab the handle here and just kind of make a wall. I'm going to give it a little bit of space off the screen because every player wants to throw the ball away off the screen and get it lost or whatever. Never trust the players. They're always trying to break your game. So we're going to create the 1, and then we're going to duplicate it. Again, just select it, hit Control D in the hierarchy. And this time, I'm going to, just to put it on the other side, Unity's coordinate space is relative to 0, 0 being the center. So this is the middle of the screen is the very center. The right side is positive and up is positive, left and down is negative. So x is negative now, but if I just delete the negative on my second wall, it just pops over to the other side because now it's a positive 8. So now Our game has some lovely walls. I'm really disappointed because they were going to be really cool brick walls, but that's okay. You can download, there's the finished project that I have for reference up on the GitHub, and I'll show you at the end how to access that. But if you want to look for reference and see my great walls that I spent so much time on, you can take a look at that. Cool. So save again before we run. And now, since it already has the box collider from the ground, box collider already adjusts to the transform and everything. This just right out of the gate, and look, see, I told you what players will do. Right out of the gate, works like a charm. And so the basketball bounces around on the screen. You can throw it in all different directions. And we've got a constrained environment that we're playing in. That's awesome. Cool. So now it's time to work on the net. This is where I'm not going to yield with the net. We need a great net asset in there. I will give up on the brick wall though. So make sure your project view here is selected, and we're going to go back to our Sprites folder. So I'm in the down in the little corner here. You can kind of navigate your hierarchy of folders here. And I'm going to click and drag my net in. And again, just kind of cheating the system. So this is a little bit bigger of an image. So if I drag it in, so I can drag it into the hierarchy, same as I could the scene, and it'll just create the sprite for us. If I drag it in, that's pretty big. I don't think this is the correct scale. I'm not a big basketball fan, but I don't think that's quite right. So again, we're just going to change the PPU, and I think we're going to want to make it 150. Make sure you hit apply down at the bottom. That looks better. Great, so we have this net object here. We go to the scene, we can see it. I'm going to go ahead and switch back to the move tool. I pressed W on my keyboard to do that. If anyone's familiar with Maya, it's the same, Unity uses the same key bindings as Maya for the tool switching, which is really convenient. Cool, so we're going to want to move that kind of to where we want the net to be. You notice it's going behind our wall here. It's maybe not what we want. On the sprite renderer, on the net, we can change the order and layer. Right now it's 0. Everything starts by default on 0. If we just move it up, there, it's on top. Easy as that. So I just set that to 1, and now our nice net is in the scene. I'm going to go ahead, make a couple more tweaks, just get it a little bit better in there. That should be fine. That looks pretty good. So that's that's pretty accurate, I think. So we're going to want to give this some physics. Now, we can't just, if we just add a box collider, right? We're going to get this. And I don't know if that looks right to you, but if it does, I have some bad news for you. That's not quite right. That's a pretty frustrating net overall. I think your players won't be too happy with your net if you go this route. The box collider automatically sizes to the sprite, and so it says, well, this sprite has this rectangle. Here it is. I'm this rectangle. We don't want that. And we could edit the collider, and we could, press this button here and grab these handles that are really finicky and try to slide them around, and that would work. But a faster trick that somebody showed me at a game jam a couple years ago is really cool, actually. So what we're actually going to do is we're going to remove the component. I right-clicked, hit remove component. I'm going to click on my object here, right-click, create empty. So this creates an empty game object nested under my main object. So now they're linked together. If I move one, it moves the other, same as Photoshop layers. Into this, I'm going to add a sprite renderer, which is the same as when we add anything else. When we add a sprite, it automatically creates an object with a sprite renderer for us. Add a sprite renderer, drag our source pixel into the sprite, and I'm going to set it to kind of a purplish color, so I know it's like a game under the hood game value. And then what we're going to do is I'm going to set the order and layer to 10 just so we can see it a little bit easier. I might even make it a little transparent so we can see a little better. And now add a box collider. Now the box collider sizes to this, and we can use the rect tool to easily just kind of scale this around and position it. I'm going to try to position it so that it loosely mimics where I would expect the ball to interact with the backboard of this net here. So put it there. And the nice thing with this approach is I can select this object and manipulate it as if it were a Unity object instead of using the really tedious box collider editing tool. The problem now is it shows up in our game, but when we're not working on it, we can just click this off. There's a slightly more complicated approach that allows it to be rendered in the scene view and not in the game, but we're gonna kind of skim over that. It is in the final project if you wanna kind of do your homework and look into that. So this should be good as far as a collider goes. I think this will do the trick for us. So let's go ahead and run it and see what it looks like. Oh, well, maybe I should throw the basketball right, huh? Yeah, that's not too bad. Oh, another note, if you didn't see just now, the basketball was behind the net, and the backboard. Now, in some cases, maybe in a more advanced workshop, you would maybe split this into some layers and do some fun layering. But in this case, I may give it more depth. In this case, we're just going to make the basketball on top. So go click on the basketball, order and layer. I'm going to set it to 3. That'll just be on top of the net. Cool. So we've got our backboard, and that's pretty great. But now we need to know that the ball went through the backboard. Before we do that, I just realized I did not name this anything other than game object, and that's a bad practice. I'm just going to call this backboard, because we always name our objects just as we always name our layers, right? Now I'm going to go ahead and duplicate this backboard object with Control D, and I'm going to rename it as Net Collider. And conveniently, even though the sprite renderer is turned off, I can actually still use the rect tool to adjust this. So I'm going to go ahead and move it and bring it right into the net. I'm actually going to sync it in just a little bit. I think there's a specific number I'm supposed to put here. No, I just kind of, I'm going to put it right about here. Generally, you just want it to be about so that the ball will have to have been entering the net a little bit to collide with it. Now, right now, as it stands, when we run this, the ball is just going to kind of sit on top of the net if it gets in or bounce off, right? We don't want that. We actually want the ball to pass through, but we want it passing through to be detected. So we want the collision to be registered, but we don't want any response to be rendered. So we can, there's this convenient little checkbox here on the box collider called isTrigger. So if we check that, what this does is it doesn't interact with physically interact with a rigid body, but when a rigid body passes through it, a script attached to this actually gets a notification that there's something going through it. Just in the way that when we click on the ball, we get a notification with a function. So we set isTrigger. Now it won't collide, but it will still act as a physical body in the sense that it detects collisions. And now it's time to add our next script. So we're going to create a new script, and we're going to call it, we'll just call it Score Zone. Great. So we created our score zone, and before we edit it, I'm actually just going to go ahead and attach it. You can attach by clicking and dragging instead of hitting add component. I'm going to go ahead and attach it so I don't forget later. Now I'm going to double click, and we're going to go ahead and go in and edit. It's the same template as before. We're going to add some functions. So we're going to need on trigger, or I should say void on trigger enter 2D. Remember, we're working with 2D. And again, autocomplete did the work for me, but generally, it's on trigger enter 2D, and then in the parentheses, a collider 2D object, so that's that collider that's attached to whatever was entering the net is passed in and enters the function in the same way. And by default, it's named collision on some things, but we want collider. Collision doesn't quite make sense because it's not a collision, it is the actual collider. I'm not sure why the template gives you collision. So I was going to kind of demonstrate, like the ball goes into the net, but we're going to, and you see in the log, but we're going to go ahead and kind of skip over that. Let's just go ahead and go ahead. What we're going to do is we're going to check if the collider, we're going to say compare tag. So we want to check if it has the basketball tag. And we'll go back into the editor and look at the tagging system in a second, but basketball. So this is a good way of checking if an object is of a certain type, because we don't want just anything, any old thing passing in there, even though there's only a basketball. This is a good practice. So if collider.compare tag basketball. So what this is saying is if this is a basketball, I don't need this anymore. If this is a basketball, let's do something with it. Cool. And what we're going to want to do, let's see here. We're going to want to implement some kind of score, right? That gets incremented when the ball enters. So we're going to go ahead and add a, oh, I'm sorry, that's going to go on the scoreboard. I'm getting ahead of myself. Let's go ahead, check if it's a basketball, and now we're going to do the debug log. Debug.log, basketball in net. Cool. So like I said, we're going to need to, before we test this out, we're going to need to go over the tag system. So you can see in the inspector when we select the basketball, it says untagged here at the top. And we see there's some default tags given to us. If we click it, we get this drop down. We don't want any of these. We're going to go ahead and hit add tag. And we're going to go ahead and click this little plus down in the lower right and say basketball. Great. Make sure Twitch is okay. Cool. So we're going to go. Now, we've added the tag, but it hasn't been added to the basketball. We just added it to the tag system. This is kind of an annoying little glitch in the workflow, in my opinion. But just go back to the basketball, select it, select basketball. Okay, now the basketball is of type basketball. Nothing else, or it has a tag basketball. Nothing else has the tag basketball. So we can reliably say only the basketball will get checked for the net. And now you can go and throw the basketball, if I'm good enough, into the net, and in the console, basketball and net. Great. If we wanted to get a little fancy, we could add some colliders to the rim. And again, I would have done that if we had more time. So great, so the basketball can go into the net. We can detect that. Something, kind of above and beyond, we could also check if it's moving down by checking its velocity. Because you don't want to be able to throw the basketball up into the net. You want it to be coming down, right? Again, I'm trying to be in the interest of time because it's already 9. We're going to skip over that. Definitely check the end code or the finished project code if you want to see how I implemented that. Cool. So we're going to kind of skip over some of those polished things, like I said, and we're going to go ahead and keep track of score now. So what we're going to want to do is we're going to go into our hierarchy here. We're going to create UI and then text. Should probably watch my monitor, not that screen. So we're going to create some text. You see it created a bunch of objects for me here. Created a canvas with the text as a child of the canvas. So canvas is a UI parent that renders all of the UI under it, right? And it manages scaling because UI is not rendered in the Unity world space by default.
It's usually to your camera, though that can vary too.
Yes, it's attached to the camera in a sense, and it scales with the aspect ratio of the camera. And an event system, which is not necessary for our purposes, but is what handles UI input, basically. So our text is hiding down here in the game view for whatever reason. It decided to live down there. If we go and look for it down here, it's not actually down there because the canvas is in overlay mode. And what that means is it's just kind of rendered in the screen space. If I go ahead and select the text and I press F to find it in the scene with my mouse hovered over the scene view, it takes me way the heck over here. And there's our game view right down there, this tiny little thing. So this is saying this is your whole screen here, and this is your puny text in your screen. We're actually going to, so we can see where our text is relative to the game, I'm going to change this to screen space. So on the canvas, select canvas, screen space, camera. And what this does, and you need to select a render camera. So just drag our main camera in. What this will do is now it's relative to the actual camera in the world. So we can just better position it relative to the world space. Now we're gonna put our text. I'm selecting, the rect transform is kind of a different style of transform. It's specifically for UI elements. And the key difference is it has this kind of like anchoring system. And so I can anchor something relative to the top of the screen, so its position is now relative to the top center. I do that by clicking on the top left little icon here, and then selecting the yellow dot indicates where the anchor will be. So I select the icon with the yellow dot in the top middle, and it says center top in the grid there.
And that also is going to change your 0, 0.
Right. Right, so that changes my 0, 0. So Y0 now is the top, and X0 is now the middle. And so now I can adjust my Y and X. I'm going to do that up here by just, like I said before, you just click on the label and drag. And now I can give it a little change. And that's basically impossible to read. So we're going to change our text. I'm going to change the alignment to center and middle. And I'm also going to kick up the font size a little bit, although the text just disappeared. One thing to note, in Unity by default, text wraps around the little bounds that you have here. And then, so you see, you can barely see, but it says new there. And then by default truncates anything that's overflowing below. In our case, we don't really care. We're just gonna say overflow. So that allows it to overflow horizontally, and we'll say overflow vertically because we really don't care. So now text can be any old size, and it's just within the bounds of that object. I'm gonna go ahead and say that's just set 0, 0, 0 as the text so that we can see what a regular score will look like. And I'm gonna set the color to this nice bright white. And now we have a score in the game. Now it's not gonna do a whole lot of anything right now because there's nothing to change it. So we're gonna write our final script for the game. Go into Project View, create C# script, and we're gonna call this scoreboard. There's a number of different approaches when it comes to handling score as data and programming flows as far as reading data and then presenting it on the UI. We're gonna kind of skip over a lot of that type of stuff just because it's way out of scope for this, but just know there's many, many ways to display a value on the screen, and this is certainly not the best way. But on scoreboard, we're gonna give it a public int score. So that's the score. That's the score that's going to be displayed. And then an update. Remember, update is called each frame. So this is a great time to check a value each frame and see if we need to update the text on the screen based on the value. So we're going to say get component text. Text. So if we just type get component text and then add our parentheses, we're going to get some red squigglies, and it's going to say, I don't know what that is, right? Namespace text cannot be found. And the reason that is because Unity has all of its UI components in a different namespace. Basically what that means for our purposes is we just need to say under using Unity Engine, we need to say using Unity Engine .ui. And that makes all of the UI elements of the Unity Engine now available to our script here. Now text is highlighted and there's no red squigglies. We can say get component text dot text, the text being displayed on it. The string value of this text displays, it says, equals score. And again, not toString. I was about to say there's an implicit conversion, but there's not. There's specific instances where there's implicit conversion. I think it's only in concatenation is actually when it is. Yeah, so it doesn't really matter. But toString is a function that's on pretty much everything in C# that says, convert this to a string. Just give me whatever it means in a string. In our case, score will just turn into a number displayed on the screen as a string. Cool. So right now, if we were to hit run, it would just show 0 because score isn't getting changed. So let's hit run just to, no, it won't show anything because we didn't attach the script. See, classic pitfall. Cool, so let's go ahead, add component, scoreboard. Great. So now it'll show 0, and we can go down here and we could maybe like change the score, and you see it actually goes up and down as we go, and we can get a negative score, and that makes sense, right? Cool. So finally, we need a way to actually change the score when the ball goes in the net. So we're going to go over to score zone, and instead of logging basketball in net, we're actually going to change the score. So we'll need a reference to the scoreboard object. So we're going to make a public scoreboard, and we're going to call that scoreboard. So there's a public variable of type scoreboard, that's our script, named scoreboard.
This is where Unity gets like very strong, because Noah's getting a direct reference to something, and this is kind of like how your code can kind of build up, and you can build more complex things.
Right, you can build a lot of inter-referencing structures that kind of, like maybe we had more than one scoreboard, and each thing increments a different scoreboard, and that's important maybe in a multiplayer game, being able to get these direct references like Dakota said, instead of any old scoreboard in the scene. So now we can say scoreboard dot, because it's a public, because score is a public variable, score, and we're going to say plus plus, which is the increment operator. Plus plus just always increments value by 1.
Integer.
Or an integer.
Yeah.
Is it not floats? It should apply to
It might
floats.
work with floats,
Yeah.
but always by 1 of whatever it is.
Yeah,
So
it's by,
an
yeah,
integer or-
exactly. I think it works with characters as well. It just
Oh.
goes to the next because characters are integers under the hood, or yeah, bytes. Anyways, that's all out of scope. Plus plus means add 1. So it's just a shortcut. We could say like score equals score plus 1, but that's just way too much writing and everyone's lazy. So we'll say score plus plus, hop back. If we hit run,
I think you have to set the reference.
you got a good point, Dakota. That was actually one of the pitfalls I was going to hit on, but I didn't intend to do that anyways. So Dakota's right. He said we need to set the reference. So we're going to go to Net Collider here and drag in our what's called text. See, this is what you get for not naming your objects. But text has the scoreboard attached to it. And so like Dakota said, this is where Unity gets really powerful. We can actually just drag the whole text object in here. And Unity knows, because it has a test attached to it, or because it has scoreboard attached to it, it will just get the reference to that attached component.
And also, like just like components before, like Noah showed, if you hit that little circle dot, it will also show up whatever's in scene that has that as well.
And it will
So,
only
yeah.
show the objects that have it, right?
Yep.
Yeah. So it's really nice, especially if you have a big complex scene and you don't have to try to find it. Cool. So save it. Go ahead and run. And finally, whoop, so you get 1 point. And maybe we can get 2 points. I'm going to cheat a little bit here. I'll just go right up through the bottom. It's 2 and 3, 4, and we'll get 1 more. Come on. Walk it along here. Yay! So
We made a game.
we made a game. You have a thing you can interact with, and you have a score. So that's basically just a game. There's play and a score. What more do you need? In our case, there's a lot more that you need, and there's a lot more that I wish we had time to do. But this is the essence of what you can do. There's, aside from, well, actually, even including the obvious, like, what if we had time? Would you say that could improve this? Maybe we can kind of, I can't live code anything, but we can kind of back and forth and work out maybe how you might implement it. If anyone has any thoughts looking at this. A timer?
Mm-hmm. It's a good one.
Yeah, that's a really good one. So you could implement a timer, probably in the same way we did the scoreboard. It sets the text to a value and update. But also, Unity has a time class that provides the time in between frames, each frame. So in update, you can subtract that time in between frames. It's called delta time from a value, and then display that value on the screen. So we could say, start at 60 when the game starts, and then subtract delta time each frame and to display that value, and it'll be a counter that goes down in seconds from 60, so you have 60 seconds.
And it's consistent because it doesn't, it's already factoring in the computer's clock. So whoever's playing it, if I'm playing on a really bad computer, it's going to still be 60 seconds.
Exactly. Another one? A start and end screen, yeah. So there's, again, a number of different approaches you could go here. You could have a separate scene that has just start, and then it loads the main scene, and then an end scene that it goes to when the timer runs out, for example. You can
also just overlay it on the canvas too?
Yep, you could also just overlay it right on top of the current canvas. There's a lot of power in the Unity canvas system, but there's a lot of stuff in Unity that was just totally out of scope for this, unfortunately. Some other thoughts, just off the top of my head. You could have a line that points where the ball is going to go, that draws that vector that you're currently working with. That's good to give players feedback to know what they're doing. Maybe change the collider on the backboard a little bit so that the end of, or not on the backboard, but on the hoop, so that the end of that rim, this one we can actually do because it's pretty small. But there's no good reason that this rim doesn't just have a little something right there, right, to bounce the ball off. And even better, if we were being real cool, it would be a circle collider, because then it'll bounce off in any old direction. And so now, this little tiny circle collider will, if I can hit it, it's my luck that I actually, there you go.
Yeah.
So now you have a little collider at the end of the net.
Another one is, you notice how Noah's like able to walk the ball. You might want to have something that checks, okay, have we hit the ground once? And then you can only click once after you've hit the ground.
Right, yeah.
And things like that.
Yeah.
So they can't just cheat and walk it all the
Yep.
way down.
That's a big one in platformers, is to check if you've been on the ground before you do like a jump again, right? And that's a hotly debated topic as to how you check for if something's on ground. But in our instance, it's literally, did it collide with maybe something tagged ground? Easy enough. Yeah, any questions, thoughts? Cool. Let's give chat and Twitch a little bit of time. And also, I'm going to, oh, it's not here. On the intro project, so like I said, there was some stuff we had to glaze over. I did this project a little bit before, put it in the oven before this, and now we can pull it out and say there's a completed one. If you just switch the branch over here on the left to finished, this gives you the full finished project. Everything's set up, rigged properly. All the scripts are commented, so they should be easy enough to look through and deduce what's going on. And you get a chance to play with it, maybe make some of the improvements that we talked about. And if you have any questions, of course, Dakota and I both are available on the Rock Game Dev Discord at any time. So if you have a question about it, just throw it and help me code, and we're happy to kind of help you get going, especially with this project or with anything else. Yeah. Any other thoughts, Dakota?
I think that's it.
All right. Thank you so much for coming, especially in the weather. Appreciate it. It looks like it's better now, so that's at least good. At least a little bit better. Yeah. Thanks so much.
Thank you.
Thank you guys. Thank everyone again for stopping by. If you feel like grabbing pizza on your way out.